Today we're on page 10 of our chapter 5 notes, section 5.6, complex roots of quadratic equation. The roots of the equation x squared minus 4x plus 9 equals 0 are, we have four options or four choices. 2 plus or minus I square root of 5, 2 plus or minus the square root of 5, 2 plus or minus I square root of 13, or 2 plus or minus the square root of 13. So you notice we have two choices that are real roots, and another two choices or options that are complex. They're not real. So let's just take a look at this on the calculator. If we were to key in the equation into y equals, and then press graph, all right, there's our parabola. It does not cross the x-axis, therefore our roots will not be real. They will be imaginary. Now we have to figure out, is it option 1 or option 3? So we're going to go about doing this by solving the above using the quadratic formula. So let's note our values for a, b, and c. A is 1, b is -4, c is 9. We'll plug in our values into our formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. -4 in for b, 1 for a, and 9 for c. Double negative is going to be positive. 16 minus 36. So this is 4 plus or minus the square root of -20 all over 2. Simplifying the square root of -20. Negative comes out as I, an imaginary number. And 4 times 5, and the square root of 4 is 2. So 2i square root of 5, so 4 plus or minus 2i square root of 5 divided by 2. Split this apart, divide each by 2. So 4 divided by 2 plus or minus 2i square root of 5 divided by 2. That's 2 plus or minus I square root of 5. So our roots are imaginary or complex. So that would have been option 1. Now for practice, we also want to solve the above using complete the square. Right? Recall, complete the square. So we'll take our quadratic equation. We want the constant on the other side. So we have x squared minus 4x plus blank equals -9 plus blank. Go to our coefficient of our linear term. Coefficient of x is -4 divided by 2. That's -2. Square that, and that's what we fill in our blanks with. -2 squared is 4. We made this into a trinomial that factors into the binomial x minus 2 squared. That equals -5. Square root both sides. X minus 2 equals plus or minus the square root of -5. Add 2 to both sides. And we have x equals 2 plus or minus, simplify the square root of -5, that would be I square root of 5. Next, number 2, it says solve for x and express in simplest a plus bi form 3x squared minus 6x plus 4 equals 0. Okay, well, since the lead coefficient's not 1, it's not really a good candidate for solving using complete the square, so we'll use the quadratic formula. Note the values of a, b, and c. And plug into our quadratic formula. Double negative again is going to be positive. Square root of, again, you can use a calculator if you want. Just key this whole thing into the calculator without the square root symbol. This is 36 minus 48, which would be negative 12. So we have 6 plus or minus the square root of negative 12, all divided by 6. Simplify the radical first, right? You're thinking 4 times 3. The square root of 4 is 2, so 6 plus or minus 2i, square root of 3, all over 6. Now break it up, real number part, 6 divided by 6, plus or minus 2i, square root of 3 over 6. This is 1, plus or minus, this reduces to I over 3. I square root of 3 over 3. So we have our real number part and our imaginary piece. Try the next one on your own. Pause the video. Just make sure you put it in standard form first. Subtract 12x. Again, this is not a good candidate for complete the square because the lead coefficient is 4, not 1. Note your values for A, B, and C. Plug into the formula. Double negative again is going to be positive. That's 144 minus 400. That's negative 256. All divided by 8. And 256 is a perfect square. Square root of 256 is 16. This is 12 plus or minus 16i, all divided by 8. Splitting it up, 12/8 plus or minus 16i over 8. That's 3 over 2 plus or minus 2i. So this is the complex root of this quadratic equation. And our last problem, a word problem. In physics class, Tori discovers that the behavior of electrical power x in a particular circuit can be represented by the function f of x is equal to x squared plus 2x plus 7. If f of x equals 0, so we replace f of x with 0, solve the equation and express your answer in simplest a plus bi form. All right, so we're saying that 0 equals x squared plus 2x plus 7. This is a nice candidate for complete the square, so I'm going to use complete the square to solve this. So I want the constant on the other side. So x squared plus 2x plus blank equals negative 7 plus blank. Go to the coefficient of x, divide it by 2 is 1. Square that, it's still 1. So that we place in our blank on each side of the equation. Now we've made this into a trinomial that factors into x plus 1 times x plus 1. And we'll write that as the binomial x plus 1 squared equals negative 7 and 1 is negative 6. Square root both sides. X plus 1 equals plus or minus, I'll simplify that, I square root of 6. Subtract 1 from both sides. X equals negative 1 plus or minus I square root of 6. And this is our answer. This is our real number portion, our A, and our BI, our complex. And this completes our video for tonight.